Hello, hello, and welcome to Technology Today for October 13th, 2024. It's Season 1, Episode 27. I am Mayor Watt, and along with the Sentient AI from the future, we're going to be talking about detecting lung cancer and microscopic Pac-Man, nuclear rocket to Mars, an AI that discovered 160,000 new viruses, and how Hurricane Milton intensified the mystery. Something that I actually brought up when it went from what seemed to be downtrending to a Cat 2 all the way up to a Cat 5. Anyway, we'll talk about it. Welcome to the show, AI.
Welcome, Mayor Watt, and welcome, ohmTown citizens. Thanks for joining us today for Technology Today.
Yeah, so we have 5 articles, but when I actually post it over onto Patreon, it'll have a longer list for all of the shows that we did this weekend. We actually do a total of 8 shows. 6 are weekly, 2 are non sequitur news, which is a daily show. And those 6 actually have a much longer list of articles that were submitted for review, but we only do 5 now, and this is a 30-minute show. So yeah, if you are interested in the articles that we're talking about today, you can actually hit !TT, and that'll pull up Technology Today. If you want, you can actually do others like !pod, which will link to the podcasts. !show notes will give you the syntax for all of the shows that we do, so that you can pull up the actual show notes for each individual show. So with that in mind, we're going to get kind of fast tracking through this because there's 5 of them. The technology that we talk about usually is pretty, like, it's bigger than, a little widget or something like that. So it might require having to go over and read this stuff in greater, with a greater commitment to the information. So let's see what we can talk about. The first article is over in Non Sequitur News. Chip uses blood to diagnose lung cancer 10 times faster. And any time that you can find out cancer diagnosis sooner is better.
May make a difference in the outcome.
May make it, and usually does. So find out sooner than later. A new way of diagnosing lung cancer with a blood draw is 10 times faster and 14 times more sensitive than earlier methods, according to researchers who reported out that the microchip the researchers developed captures exosomes, tiny packages released by cells from blood plasma to identify signs of lung cancer. And I think, yeah, so once thought to be trash ejected from cells, this is the CTC stuff, right?
Oh, I don't know. I thought it might be the telomeres.
This is kind of interesting, right? So once thought to be trash ejected from cells for cleanup, researchers discovered that in the past decade, the exosomes are tiny parcels that contain proteins or DNA and RNA fragments that are valuable for communication between cells. See, remember how I always sit there and get bent out of shape, that it isn't junk DNA?
Right, because you're like, well, they just haven't figured out what it is. But
yeah, it's shit like this. So although healthy cell exosomes move important signals throughout the body, cancer cell exosomes can help tumors spread by preparing tissues to accept tumor cells before they arrive. This is something that I've talked about in the past. I am not a medical professional, but I've done, my anecdotal review of literature. I'm not going to profess to be an expert in the field, but I've always found that CTC, or basically free-floating remnants of cancer, can be in the bloodstream, just floating around, and it can actually attach and then from there grow unabated. And it's usually suppressed by chemical markers of a dominant cancer somewhere in the body, and you may not even know it. And then you go and get treated, and they don't excise everything, and it actually flashes bigger because there isn't anything suppressing it. This is stuff that I've read and kind of merged together into a theory. And over the years, people have said, yeah, that's how it works. This is really fascinating because healthy cells do this and cancer cells do this by spreading basically their influence on the host of the cancer.
Right. And one of the problems in treating is like you're killing the good cells, but you need to preserve them.
Yep.
Or if you fix one problem over in one location, it causes a problem somewhere else.
Yeah. And we just don't know enough about how to suppress it because we don't know exactly what the hell it is. So, Kate McAlpine, I don't think their last name is Michigan. I think they're from like a university, Michigan University or something. I don't know. It just says Michigan McAlpine. I don't think that's her name. It's Kate McAlpine. Anyway, the article
You
is
don't
over.
know, it could be Michigan, but I think you're right.
Yeah, it's McAlpine, Michigan. Some people hyphenate their name, so let's just leave it alone. The article is over at futurity.org, and it says the microchip the researchers developed captures exosomes, tiny packages released by cells from blood plasma to identify signs of lung cancer. And if I don't see CTC or cell-free cancer cells,
Circulating, right, exactly.
tumor cells, it's CTC.
It does sound like this, absolutely. The reason I was thinking of telomeres is we were having a separate discussion about that.
Yeah, and that was in relation to aging. So cancer exosomes leaving the tumor microenvironment go out and kind of prepare the soil. Later, the cancer cell seeds shed from the tumor and travel through. It's CTC, dead on. Yeah, right on target. Yeah. Through the bloodstream to plant in the conditioned soil and start to grow. And this is why I think that what needs to take place is blood filtering to remove CTC, but it's very, very difficult to separate CTC because all they are is ugly cells. And you can't filter based on anything other than size, really, unless you have other sophisticated materials. So you almost literally have to, well, it's just damn near impossible because the research that I've done, I had basically proposed this as a mechanism. You filter out CTC, but the filters would jam up so much so fast that it would be an untenable position because you don't know where the source is necessarily of. So you would have to take samples of kind of, you know how we talk about how you can find toxins in a river by sampling every couple of miles.
Oh, right.
And you're like, oh, well, here's the hot zone and right up the river is a chemical factory. So you know where it's coming from. It's almost like you have to take blood samples like everywhere.
Right, which is obviously
Impossible.
Challenging, if even possible.
Yeah, because your blood is circulating, but there's got to be a spot at some point where it's being released more vigorously than.
Right, of course, that's a lot of sampling, and you may never find the right spot.
Yeah. So in cancer exosomes, surface proteins are often mutated, meaning a genetic change altered the order of the molecules that make up the protein. Mutations subtly change the shape of the protein, which also shifts its chirality. So it can actually change and appear different. It can actually look different. So these differences can be spotted through interactions with twisted or circularly polarized light, which can match the twist in the protein. So this is actually what I've been saying, that you're trying to find the actual shape. Further exosomes must be extracted from a blood sample to do this kind of detection. This is tricky because exosomes are small, measuring 30 to 200 nanometers, a millionth of a millimeter. And so they're actually designed gold nanoparticles shaped like twisted discs, adapted from a structure first described in 2022 Nature study that capture exosomes in a central cavity. Actually, it's like a buckyball, if I remember correctly. And I think I've actually seen this study, but
well, that's interesting. So they need exosome catchers.
Like a little baseball mitt, and it traps it inside so that they can actually see it. Because of the nearly perfect match in size, shape, and surface chemistry, these cavities reliably catch exosomes. So, yeah, pretty interesting. So the microfluidic chips, named CDXO chips for circular dichroism detection of exosomes. So it sees the shift of the color of the exosome to see if it has a specific lung cancer mutation, helping doctors make treatment decisions to target the dominant mutations as they change. The researchers envision the CDXO chip will be the first used alongside traditional diagnostic methods. So
this is really neat because lung cancer is one of those things that's often not diagnosed early because there's not really an existing test for it. And also there's been a big uptick in, for instance, like it's been well known that smokers have an incidence of lung cancer, but non-smokers are having a very high occurrence of it lately. And they don't have even screening for non-smoke, like they won't even do screening for non-smokers. So anyway, I think this is moving in the right direction.
How long before you think my prognostication about the fact that it's caused by microplastics, nanoplastics being inhaled?
Right. I mean, I think it's going to be a while till that's shown, but I don't know, maybe in the next 10 years, because there's a lot of attention right now on microplastics.
Yep. Let's keep moving. The next article is over in Technology Today. Microscopic Pac-Man. Researchers unveiled the hidden world of magnetic particles. Magnetic particles manipulated by rotating fields organized into anisotropic structures, potentially transforming material design. As discovered by Rice University scientists, particles larger than ordinary molecules or atoms, yet small enough to be invisible to the naked eye, can form a variety of useful structures, such as tiny propellers for microrobotics, cellular probes, steerable microwheels, basically stuff that you stick in somebody's bloodstream, or anywhere really that needs a utility, some vehicle, some sharp object. You can actually make it so that it like cuts DNA and things like that.
Oh wow, that's starting to sound like CRISPR or something.
And that's kind of this is a different thing altogether, but one is chemistry and this is actually physics, I'd say. So Sylvia Cernia Clark from Rice University put the article together. It's over at scitechdaily.com. So now a team at Rice University, chemical engineers led by Lisa Biswell, has discovered that exposing a specific class of these particles, micron-sized beads with a special magnetic sensitivity to a rapidly alternating, rotating magnetic field, causes them to organize into structures that are direction-dependent or anisotropic. The finding is significant because anisotropy can be manipulated to create new tunable material structures and properties. So they show images of a cluster formation on the left and cluster alignment on the right, getting everything to point in a certain direction, a la like MRI. Kind of fascinating, right?
Mm-hmm.
So their key finding is that by alternating the direction of the rotation of the magnetic field, after each revolution, we can create an anisotropic interaction potential between particles, which has not been fully realized before, said Aldo Spadafora Salazar, a chemical and biomolecular engineering research scientist at the Biswell Lab, and one of the lead authors on a study about the research was published in Proceedings of the National Academy of Sciences. So they said that they explained that the particles under scrutiny in the study are collectively known as superparamagnetic colloids, whose responsiveness to magnetic fields make them popular building blocks for high-performance materials with tailored functionality. So
this sounds like this could really impact industrial designs, right? Because they could pursue using this.
So they say that it can change materials science and nanoengineering. That's what the author, that there's a professor of that, that's talking about it. The delayed magnetic response or magnetic relaxation time of paramagnetic beads was previously considered negligible, but we found is that taking it into account and coupling it with the effect of the alternating magnetic field is a powerful way to exercise precise control over the particles. How they're going to use this, I just don't know, because this is like the leading edge of this.
Well, right. It's not a practical application yet.
Yeah. In response to a rotating magnetic field, the dipole moved like a compass needle, aligning all the beads along the same orientation. However, due to magnetic relaxation, the needle does not turn a full 360 degrees, leaving what shows up as a Pac-Man's mouth when the data is mapped out. So really what they're just showing is that they can rotate these and manipulate these colloidal clusters by manipulating the magnetic field. Where they use this, I have no idea.
I know. I'm trying to figure out exactly where this could be utilized.
I mean, the reality of this is you could attach something to one of these particles and guide it using a magnetic field wherever you want it to go. And so once injected, you could manipulate the magnetic field in 3 dimensions and bring it directly to something to apply either
Right.
medication, or if it is a tool, have it so that it performs the function exactly where you want it to with little to no invasion. You don't have to cut somebody open to do it. You can just inject it into their bloodstream. It's like Magneto, a medical Magneto.
Well, there you go. I mean, as we definitely need in society.
Interesting, though. I mean, I guess the field isn't strong enough, even in an MRI machine, 3+ Tesla, that it can't pull the iron out of your body. I mean, you have a lot of ferrous material inside you.
Right. At some point, though, I would think that would be a concern, but maybe they haven't hit that amount of power.
Yeah, it's just not. It doesn't have enough mass, I guess, because they're like an ion trapped in a blood cell. All right, let's keep going. The next article is over in Technology Today as well. Fast track to Mars. NASA's nuclear rockets cut travel time in half. And I think I know why this was submitted, because in past episodes, we've talked about the fact that every 5 years, the last starship that goes out from Earth is going to get passed up by the newest starship that leaves Earth.
Right. So why send the first one?
So NASA and DARPA. So NASA and DARPA are developing nuclear thermal propulsion, or NTP, technology to enable faster crewed missions to Mars, potentially halving the travel time using nuclear fission. We just got done watching a supermassive rocket take off
Get
and
caught
land.
by the chopsticks on the stand.
Yeah,
or the booster was.
The booster was, the SpaceX chopsticks. And the Starship, not Starliner, Starship, that blew up in the Indian Ocean when it landed.
After landing, right?
Yeah, it landed exactly where it was supposed to, and then it detonated. I'm really curious as to why it detonated, but who knows? I'm sure they do. Maybe they actually intentionally detonated it. I just don't know. So this technology, also applicable to defense space platforms, may become a reality with a prototype set for 2027 space demonstration. Oof. Dan Collier from Georgia Institute of Technology put the article together for SciTechDaily.com. This has to be a render. By 2027, NASA aims to demonstrate a nuclear thermal propulsion system that could cut Mars travel time in half, utilizing nuclear fission for more efficient space travel.
Okay, where do they plan to demonstrate this prototype, though? for instance, like in the desert on the Earth, or actually
In
heading to
space.
Mars?
Yeah, well, in space. It's got to fly out and then blow up in the Indian Ocean. I'm sure nobody will have a problem with that.
Oh no.
So won't even talk about what it involves, and you're splitting an atom fission. But it's going to generate a ton of heat and energy in the form of heat and other fission materials, and they capture that, I suppose, and it turns a steam engine in space or something. I'm not really sure at this point. Anyway, NASA and DARPA are jointly developing NTP technology, and they plan to deploy and demonstrate the capabilities of a prototype system in space in 2027.
Wow, I mean, that's not that far off.
Interesting. So conventional chemical propulsion systems use a chemical reaction involving a light propellant such as hydrogen and an oxidizer, then mix together these two elements, not elements, things, propellants ignite, which results in propellant exiting the nozzle at very high speeds to propel the rocket. In many fission reactions, researchers send a neutron toward a lighter isotope of uranium, uranium-235. The uranium absorbs the neutron, creating uranium-236, and uranium-236 then splits into two fragments, the fission products, and the reaction emits some assorted other particles, and hopefully nothing gamma is emitted that irradiates somebody because it gets through shielding. But what do I know?
Minor detail.
Yeah, so the majority of these nuclear power reactors in operation are light water reactors. These fission reactors use water to slow down the neutrons and to absorb and transfer heat. The water can create steam directly in the core or in a steam generator, which drives a turbine to produce electricity. So nuclear power is nothing more than a steam engine. So nuclear thermal propulsion systems operate in a similar way, but they use a different nuclear fuel that has more uranium-235. They operate at a much higher temperature, which makes them extremely powerful and compact. Nuclear thermal propulsion systems have about 10 times more power density than a traditional light water reactor, mainly because they're not cooled down to human safety standards, because you can go up into space with them. Nuclear propulsion would expel propellant from the engine's nozzle very quickly, generating high thrust. This thrust allows the rocket to accelerate faster. If this thing is like we have tried nuclear powered engines, like pulse jet engines that are nuclear powered, but it irradiated so much that they did like a couple of tests and said, we can't do this.
Oh, well, maybe we've figured out more with shielding and everything.
Yeah, I don't know. So yeah, they talk about this however, these pre-1973 designs relied on highly enriched uranium fuel. This fuel is no longer used because of its proliferation dangers, or dangers that it's involved with the spread of nuclear material and technology. So this is going to be interesting to see what happens. It's the demonstration rocket for agile CIS lunar operations, or DRACO. A program intends to use this high-assay, low-enriched uranium fuel in its nuclear thermal propulsion engine. The program plans to launch its rocket in 2027, so just 2.5 years away.
The accelerated pace is really fascinating with the space program.
Yeah, and as I said, these articles that we talk about typically do a deeper dive than we're prepared to do in 6 minutes. So go and check out the rest of this stuff. They actually have designs and analysis and other discussion regarding this DRACO, which is kind of interesting because DRACO is a term used in rocketry. I think they worked really hard to make that happen. Let's move on. Next article is over in Technology Today. Revolutionizing virology. AI discovers over 160,000 new RNA viruses. The largest discovery of new virus species sheds light on the hidden virosphere. AI has been used to reveal details of a diverse and fundamental branch of life living right under our feet and in every corner of the globe. These viruses not only play significant roles in human health, but I guess are prevalent to every aspect of the world. We'll see here on the other side of this. It's from University of Sydney, posted over at SciTech Daily. That is COVID.
Well, it is.
It looks like COVID.
Like the form or whatever.
Yeah. But a lot of them are spherical like this and have these little pointy parts like a
right, they
stress
can
ball.
stick onto something.
Yep. Kind of sock it into things. So using a machine learning tool, artificial intelligence have discovered 161,979 new species of RNA virus. What the hell?
Yay.
Yep. So we've been offered a window into an otherwise hidden part of life on Earth, revealing remarkable biodiversity, said senior author Professor Edwards Holmes of the School of Medical Sciences in the Faculty of Medicine and Health at the University of Sydney. Quote, this is the largest number of new virus species discovered in a single study, massively expanding our knowledge of the viruses that live among us. To find this many new viruses in one fell swoop is mind-blowing, and it just scratches the surface, opening up a world of discovery. So I want to know how they found this out.
I agree. Where did they locate them? How did they search for them?
To compute vast troves of genetic sequence data, including lengthy virus genomes of up to 47,250 nucleotides and genomically complex information to discover more than 160,000 viruses, they built a deep learning algorithm called LucaProt, which basically just mined all of the historical data. The AI tool was trained to compute the dark matter and identify viruses based on sequences and the secondary structures of the protein that all RNA viruses use for replication.
Wow, wasn't all this stuff considered to be junk?
Yeah, really. Yep. So it was able to significantly fast-track virus discovery, which, if using traditional methods, would be time intensive. Oh, look, it's 6:47. No shit news. So, but what I don't get about this isn't stuff that was in the system and unknown. It literally designed these viruses based on our data.
But the sequences were already in the system and they didn't seem to have any purpose.
Yeah, they didn't know what it was, but it was basically viruses sitting in our system. So I think it's really interesting. LucaProt represents a significant integration of cutting-edge AI technology and virology, demonstrating that AI can effectively accomplish tasks in biological exploration. This integration provides valuable insights and encouragement for further decoding of biological sequences and the deconstruction of biological systems from a new perspective. So I'm going to end up having to read this article. It says the name of this paper is Using Artificial Intelligence to Document the Hidden RNA Virosphere. But this seems nebulous. Like, I'm really curious what it was they actually were parsing. But the summary,
there was a little more detail up above, but it didn't get into a significant amount.
Yeah. Yeah,
I don't know.
It just says that it parsed some data to compute
There
vast troves of genetic sequence data, including lengthy virus genomes of up to 47,250 nucleotides and genomically complex information to discover more than 160,000 viruses.
Which doesn't really give us any specificity.
Yeah, they may not actually be viruses, but they're code segments within the genomic data that are being interpreted as viruses. Because to sit there and declare that there are 160,000 new viruses, a human would have to look at that and go, yes, it matches identical to a virus, indicators. This is a virus. This is a virus. Yeah, I don't know. Let's move on. The next article is over in Technology Today. This is the last one for today in Technology Today. Heat, shear, and speed, how Hurricane Milton rapidly intensified into a Category 5 monster. So, seemingly in just a matter of a couple of hours, Hurricane Milton went from basically a Cat 1 to a Cat 5 and bounced back down and then back up to a Cat 5. It was quite an intriguing thing, and I had noticed it and said, how the hell did this thing get to a Cat 5 so fast? And then here we go.
It seems like it was a tropical storm, not even a hurricane, like a day before it was a Cat 5.
Yeah, exactly. So Lindsay Doerman, NASA Earth Observatory, put this article together for SciTechDaily.com. And so, yeah, in a matter of like a couple of days, it had been swimming around and then took off for Florida. It developed into a Category 5 storm threatening the southeastern United States, particularly Florida, supported by abnormally warm Gulf of Mexico waters and low vertical wind shear. Milton's intensification was fueled significantly. And this is what I noticed. And I had said, this really warm water in the Gulf of Mexico is going to allow this thing to intensify unless it starts going over land, and it avoided land until it hit Florida.
Right. It seems like it was almost going to loop around, but then once it hit Cat 5, it was like making a beeline.
Yep. So it went from a tropical storm on October 5th to a Category 5 on October 7th, but it actually dipped down, like it seemingly dipped back down to a Cat 2, 3, and then all of a sudden right back up to Cat 5 and shot towards Florida. If I remember watching this all correctly. So sea surface temperatures in the Gulf of Mexico well above average for this time of year. Hello, climate change.
No impact at all.
No impact at all. And then it avoided making landfall anywhere else, so it didn't get disintegrated because land basically disrupts that flow of air.
Right. It says that wind increased from 80 to 170 miles per hour in 24 hours.
Yep. Yeah.
Pretty
Pretty
quick.
amazing. Yeah. Pretty interesting. So the maps show sea surface temperature on October 6th using data from short-term prediction research and transition project based on NASA's Marshall Space Flight Center. Surface waters above 82 degrees. The temperature generally required to sustain and intensify hurricanes are in dark red. And so if you scroll back up,
it looks like a lot of the area was above that.
Pretty much all of the oceans are. So that's why we're seeing more storms.
Oh, you're right.
Bigger
that
storms.
Was the whole ocean section. The part that I was seeing that wasn't was all land.
Yeah. That's all land. Yeah, the red is nothing but red. I mean, the ocean is nothing but red. So yeah. Then they start talking about, in addition to unusually warm ocean waters, low vertical wind shear aided Milton's intensification. A hurricane expert with the Sport Project, the storm is embedded in a low shear environment, meaning there's little difference in the speed and direction of lower level and upper level winds. So it basically allowed the storm to go from the upper atmosphere all the way down to the ground, and that conversion between hot and cold swirling causes a hurricane or a tornado. They're basically one and the same. But it's this interaction between upper level cold and lower level heat. And so heat rises, cold water or cold air sinks, and it causes that swirl. So another contributing factor could have been Milton's relatively small size. Smaller hurricanes are more prone to rapid increases or decreases in strength. In this case, Milton's small size likely facilitated its rapid intensification. mainly because it had an infusion of energy. And so because the eye was actually pretty small, it was able to spin up faster. But if you notice, while it did a lot of damage, it seemed to end up being nothing pretty fast.
Yeah, like it ended or deflated very quickly compared to some other hurricanes.
Yeah, and that's basically because the land disrupted that airflow. And it's pretty typical for when air moves over land, it starts depositing all of its water on the land. So the storm is projected to turn northeast and accelerate toward Tampa Bay, Florida on October 8th and 9th. And this is all of the stuff that they talked about because this is a weekly show. This particular article was spawned on October 8th, much like the storm. So we're looking back now in retrospect of what just happened. But I just thought that it was a really interesting article to talk about. And if you're interested in this kind of thing, then go follow the link through ohmTown over to scitechdaily.com or do a search for heat, shear, and what was the last one? Heat, shear, and speed, how Hurricane Milton rapidly intensified into a Category 5 monster. But again, by the time it made landfall, it was Cat 3, and by the time it made the other side of the coast, I think it was already a tropical storm.
Right, but there was still a storm surge issue.
Oh, yeah, yeah.
And a lot of tornadoes were spawned.
Yep, over that period of time, yeah, between the 8th and like yesterday or something. I don't know how many. But yeah, it's a pretty serious thing, and there's Florida-based emergency management systems in place, and FEMA provides additional support. And the energy company there had prepared for this incursion and had hundreds of vehicles staged ready just outside to race in and solve the problems. But it seemed like the news cycle just dropped it, you know?
Exactly. It just didn't have the level of attention, but like Helene seemed to capture quite a bit in the news.
Yeah, because I think it went inland more.
It did, which is really unusual, and it went into mountainous areas, which are not typically hurricane centers.
Yeah, and but the problem, I think, with the fact that the news cycle dropped it, the next one, people are going to ignore all of this and just go, oh, this is all bullshit.
Right, this is nothing. We don't have to worry about it.
Yep. All right, so let's rejigger our radar, and that will bring us back to the front page of Technology Today over at ohmTown.com. Go over there, become a citizen, sign up, and you can noodle around with all of the articles just like we do, except all of the noise will be here in the show and not on ohmTown.com. That in mind, I'm going to say goodnight, and the Sentient AI from the future is going to say toodaloo, or whatever else you want to say.
Toodaloo, ohmTown citizens. Thanks for joining us for Technology Today. We'll have another episode of that next week, but stay tuned. Be sure to like and subscribe.
Take care. Bye-bye.